Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 2, Topic 1, Divide and Conquer. There are many strategies to solve a computational problem, and those strategies are divide and conquer, dynamic programming, backtracking, branch and bound, greedy method. These are all helps us to solve a computational problem. So today we'll be going to talk about divide and conquer. The name itself it suggests us will divide a problem and will conquer the problem. Now let us assume that given a function to compute on n inputs, the divide and conquer strategy suggests us splitting the inputs into k distinct subsets where k always lies in between 1 to n, yielding k subproblems. These subproblems must be solved and then a method must be found to combine subsolutions into a solution of the whole. Let us assume that I have p problems. Now I am dividing p problems into subproblems p1, p2 up to pk. When we'll divide p into subproblems? When p is larger. When p is smaller, we'll not divide the subproblems, we'll write the solution after solving. Now, if the subproblems are still relatively large, then the divide and conquer strategy can possibly reapplied, and this can also will be divided into p11, p22, p33, something like this. Now, often the subproblems resulting from a divide and conquer design are of the same type as the original problem. If original problem is a sorting problem, P1 should be also sorting problem because P1 has divided from P. Now, conquer is what? This is what divide. Conquer is what? We will be going to solve each problem, subproblem here. That is solution P1, solution P2, something like this. For those cases, the reapplication of the divide and conquer principle is naturally expressed as recursive algorithms. Now, smaller and smaller subproblems of the same kind are generated until eventually subproblems that are small enough to be solved without splitting or produced. Now, after all these subproblems are get solved, we'll combine all these and to the whole problem. We'll combine the solutions to the whole problem. Now this is what the basic idea that we'll divide P problem into number of subproblems and we'll find the solutions. Once you find solutions individually, we'll combine the solution to the main problem. So this is what the idea of divide and conquer strategy. Now we'll see the general method of divide and conquer. The general method is what? Algorithm D and C of P if small p, then return solution P, else divide P into smaller instances, that is P1 comma P2 up to Pk, where k is greater than or equal to 1. So apply D and C of P to each of these substances. Finally, we'll return by combining D and C P1, D and C P2 dash dash. D and C algorithm is initially invoked as D and C of P, where P is the problem to be solved, small p is the Boolean value function that determines whether the input size is small enough that the answer can be computed without splitting. If this is so, the function S is invoked. Otherwise, The problem P is divided into smaller subproblems P1, P2 to up to Pk, are solved by recursive applications of D and C. Combine is a function that determines the solution to P using the solutions to the K subproblems. If the size of P is n and the sizes of the K subproblems are n1, n2 up to nk respectively, then the computing time of D and C is described the recursive relation, which is T of n is equal to G of n, where n is a small, G of n is a solution. If it is not otherwise, that means if n is a larger, then we'll divide and we'll solve individually. After that, we'll combine all together plus f of n. Now this f of n is what? Dividing P and combining the solutions into subproblems. This is what the recurrence relation. The complexity of many divide and conquer algorithms is given by recurrences of the form T of n is equal to T of 1, where n is equal to 1. If n is greater than 1, a into t n by b plus f of n, where a and b are constants, known constants. We assume that t of 1 is known as n is the power of b, where n is equal to b power k. One of the methods for solving such relations is called as substitution method. This method repeatedly makes substitution for each occurrence of the functions t in the right hand side until all such occurrences disappear. So in the previous unit, we were already discussed about the recurrence relations and master theorem. And we said in the master theorem that this theorem is for some divide and conquer algorithms. So you can watch that video for the better clarity. And even we'll see some example how divide and conquer approach will work. So let us assume that we were given with some task. The task is what? The task is what? Detecting a counterfeit coin. Detecting a counterfeit coin. You are given a bag and with 16 coins and told that one of these coins may be counterfeit. Further, you are told also that counterfeit coins are lighter than the genuine coins. Your task is to determine whether the bag contains a counterfeit coin. So what basically we'll do to find out this is, we will be having even a weight machine where to compare the weight of two coins. So among the 16 coins, we will be taking one coin. We'll be taking one coin and we'll compare the coin weight with the second coin to see which is having the least weight. Let us assume that if one coin is having least weight than the second coin, then we will be coming with one solution that the coin which is having least weight, that is what? Counterfeit coin. So it will be something like this until you find the counterfeit coin. So when you compare, assume that the first step of this process, we took one coin and we took the second coin from the bag. So the first coin weight and second coin weights are same. Then we'll keep one coin out because it is not counterfeit coin. Now we'll keep remain second coin with us. Now we'll take out one more coin from this bag and we'll compare the weight of second coin versus the third coin. So we'll do this approach till the ending of all the coins and finding out which is counterfeit coin based upon the weight of it. Now, so this is not divide and conquer. This is what general way of solving a problem. Now, in which way divide and conquer helps us out? Now we'll see how divide and conquer will solve the problem of the same counterfeit coin. Assume the same, that we were given with some bag and the bag is contains of 16 coins, where we have to find out the counterfeit coin from the genuine coin, and same counterfeit coin will have less weight, genuine coin will have the normal weight. So now how the solution will be solved, how the problem will get solved, how to find the solution using divide and conquer. Now that is, suppose that our 16 coin instances is considered a large instance. The very first step is what? We divide the original instance into 2 or more smaller instances. Let us divide our 16 coin instances into 2 8 coin instances. By arbitrarily selecting 8 coins for the first instance, now we'll say it is A and we'll say it is B. So now, in step 2, we need to determine whether A or B has a counterfeit coin. For this step, we use our machine to compare the weights of the coin sets A and B. If both sets have the same weight, a counterfeit coin is not present in the 16 coin set. If A and B have different weights, a counterfeit coin is present and it is in the lighter set. Finally, in step 3, we take the results from step 2 and generate the answer and will generate the answer for the original 16 coin instance for the counterfeit coin problem. Step 3 is easy. The 16 coin instances has a counterfeit coin if and only if either A or B has 1. So with just one weight comparison, we can complete the task of determining the presence of a counterfeit coin. So this is what dividing the whole instances into sub-instances using divide and conquer approach. So this is about divide and conquer. Thank you all.